Earlier in the course, we considered the function y equals x to the x. And we took a derivative using logarithmic differentiation, and we could apply the first derivative test to find out the function decreases to e to the minus first and increases after that. And that much work we had done previously in another video. I took the second derivative here. I didn't show any work. It might be a good exercise for y'all to pause the video and see if you can establish the same second derivative that I have here. But once you believe me that this is the second derivative, we can do the following analysis. I know that x is always bigger than 0. So this is a positive number. This is a positive number. So this first term is a positive number. This is a positive number. Something squared is positive. So I'm adding two positive quantities. The second derivative is always positive. So I know my function decreases then increases, but I know it's always concave up. That's not what I wanted to talk about in this video, though. I want to talk about the limit as x approaches 0 from the right-hand side of x raised to the x. Because we've graphed this function before in our graphing calculators, and it looks like we are actually approaching a limit there. So, what I notice now is that the limit as x approaches 0 from the right-hand side of this x to the x, this is in the format of a 0 to the 0, an indeterminate power. So let's see if we can evaluate this limit using L'Hopital's rule. All right, so we have the limit as x approaches 0 from the right of x to the x. And I want that to equal something, or I think that equals something. So instead, I'll evaluate the limit as x approaches 0 from the right of the natural log of x raised to the x. Because if I can get this to equal a value, say m, then this question mark will simply be e raised to the m power. The first thing I can do is move that x out front. And what I realize now is that this is a 0 times infinity, and in fact, this is an example we did earlier in this unit. I was like rethinking it as dividing by 1 over x. And now I've rewritten this as an infinity over an infinity. Oop. X is approaching 0 from the right-hand side, and I can use L'Hopital's rule. 1 over x all over minus 1 over x squared. Multiply by the reciprocal of the bottom, and I'm looking at a minus x, and I get 0, remembering that this was the value m. So I can now conclude the limit as x approaches 0 from the right-hand side of x to the x is e to the 0 or 1. Going back to my diagram, what I can tell you now is that there's not a gap here. There's an open circle. I have a discontinuity there because my domain doesn't include 0. The 0 to the 0 here is undefined, but as the x's approach 0 from the right-hand side, they get closer and closer to 1.